Hey everyone, welcome back to Better Biomed. I have a second example. This is a second light source, and it's not in as good of a condition as the other one. We're going to go through some of that, but this one here, I tried some of my previous experience to get it to pass and to get it to work, and it just didn't work out in my favor. It did have a burnt 6.3 amp fuse right here, and I replaced the fuse. I took out the bulb to see if this was like my other light source, which it would turn on without the bulb inserted. This one does not. It popped the fuse as soon as I gave it power, and here we are. So that means we could very well have a problem with the power supply. I don't know yet. I'm just now taking off the cover, which you can see the dust. This is why I'm telling everybody, these things need to be preventive maintenance. I've got dust bunnies sitting back here on the grill. I already wiped a couple of them off. And there's definitely a lot of dust bunnies floating around inside this machine. So that is going to be floating around. See that? And it can get blown out on your sterile field. They're very light and they can fly for many feet once these fans are turned on. Look how dirty this fan is. It's just what I'm talking about, guys. These things have to be clean. Now, I have no real evidence. There's no discoloration or anything that I can tell. Oh, maybe a couple problems here. I might have a couple problems. Whew. One of the problems I see is right here on the power input module. Okay. Alright. So I do have a problem with this. So you can see that we have neutral and ground, and then we have hot. Well, the ground, there is a bonded connector right here. It's supposed to be on that side. So that is the correct way to do it. And these two in the middle, I mean, you could do it the other way, but it should be on the bonded terminal. These two over here, we're going to have to separate those to test this guy. Gosh, popping fuses. Okay, here we go. We're bypassed. And that means the fuse is taken out of the circuit. Let's move this guy over so that y'all can see my meter. Look at these dust bunnies. That's right near the exhaust fan, and that gets blown out onto your sterile field. Okay, we're on continuity. And let's see, let's push this guy right up in here. And let's test this guy. Okay, so I have no dead shorts. Let's try dead short to ground. No dead shorts there. Now, I don't like the way the ground was connected on that block. There was a special terminal for it. I'm not even going to look at the legend to see if that was the short. We are going to go right over here to the power supply itself, and let's test for a short on the power supply itself. Okay, we're good. Now there's one other thing I want you guys to see, and I'm going to have to disconnect my phone to get you guys in there. Is another problem that we have with these systems. Gosh, I'm right by the high voltage tank too. See this wire right here? That wire is a silicone wire and is rubbing right here on this panel, and look how it's discolored. It's probably arcing right there to the aluminum. I don't know if I can get any hot spots shown on it. That silicone wire is clearly rubbing right there and maybe sparking through. Now the best way to do that would be with a high potential test on that wire, which I do have a high pot tester. Maybe I will show you guys how to do that test. So you can see the terminals that the wire is going to connect to is down here. So even if the bulb was not in circuit, if this guy's rubbing directly up against metal, and if it is shorting through the silicone jacket, then it's arcing the ground, and we have an issue. So you can see how dirty it is. That is an absolute no-go. Suspect are going to be the power supply and that wire right there is definitely going to be suspect. So one of the ways that we can test that is to disconnect that wire so that the terminal is just sitting in the air, and that way there it shouldn't be rubbing up against that ground. The other thing is to shove a piece of plastic in there and see if now it powers up without popping a fuse. It's going to be tricky, guys. These things are always fun, and as they get older, you're going to see more of that kind of stuff right there. Anyway, guys, that's just a really quick check on this. I'm going to have to dig on this light source. It's probably got a power supply issue. Since the bulb was no longer in circuit, there was no load on the power supply, and it popped the fuse almost immediately. Now, these power input modules, they look pretty fresh. It looks like it has been changed out recently. And if it's been changed out recently, that means that somebody might have had those leads on the wrong terminals. So the first thing I should do is hook these up to the correct terminals, including the ground. It should be connected to the bonded ground terminal. And then we'll go ahead and power it up and check it out. Just a little update, guys. This one here, I just checked the terminals, put the ground on the bonded ground instead of having it connected to the neutral, and I did find half of a choke floating around down there by the fan. That's a huge no-go, because if it binds in that fan, then it's going to prevent this bulb from cooling. Look at those big old nasty things. The wire is away, and I just screwed this guy in, and guess what? Folks, we have liftoff. We have power. So, whenever you change out these ports, make sure that your terminals are on correctly. Check the legend on the side if you don't know, and if anything, take a photo. Take a photo before you disconnect, alright? You can see that it seems to be lighting up good. I'll shut it off. The bulb does have a little bit of arcing on the parabolic. Not too bad. Let's place it in. What do we got? We have a light source, folks. Or at least we did. Well, you win some, you lose some. And there you have it. Terminals were part of the problem. And if anything, right now we have a bigger issue. Maybe it popped the fuse again. I did put a much smaller fuse in this time. I put in like a 1.2 amp instead of the 6 amp. So I bet you it popped that fuse. 1.2 amp is nothing, but I just wanted to be safe, and I'll always put in a smaller fuse just to be safe. Obviously, when that bulb kicked over, remember I said in my other video that these things use a high voltage, low amperage to get the bulb going. Once the bulb is going, then it switches over to a low voltage, high amperage to keep the ignition going and to keep the bulb lit in the arc. But switching over to high current sucked too much current. I bet you it popped the fuse. Anyway, there you have it, folks, and that was my update. Thanks for watching.
If you enjoyed this video, don't forget to give it a thumbs up and subscribe for more content. I'd love to hear your thoughts, so drop a comment below with what you'd like to see in future videos.